Hi there, welcome to this Azure Databricks tutorial. Whether you are a data engineer or a data scientist or a person who works on the big data analytics, this video is for you. Azure Databricks is a fully managed cloud-based big data and machine learning platform which helps you to analyze any amount of data. Suppose you are working in a big organization where you have a need to perform machine learning as well as doing the data engineering or big data analytics. Everything you can do with the help of Databricks. Microsoft collaborated with the Databricks, and that's how they are providing Databricks solution into the Microsoft Azure cloud. And that's why it's known as Azure Databricks. Of course, it is a fully managed service, and in this video you will get what is the difference between just the Databricks and what are all other benefits that you are going to get with Azure Databricks. In this video, you will get to know what is Azure Databricks, who is Databricks, what is the difference between a Databricks and Azure Databricks. Furthermore, we will create the workspaces and clusters in Azure Databricks, and then we would get to know the architectural fundamentals of Apache Spark in Azure Databricks. You would get to know all the lab sessions too, where you would practically try some of the coding, and so that you would feel confident whenever you are going to use Azure Databricks. And at last of this video, I'm going to explain you the best practices so that you can implement the Azure Databricks solution for your organization efficiently. So what are you waiting for? Let's get started. Azure Databricks is a very important part of Azure Data Engineering. This is part 1 where we are going to discuss what is Azure Databricks and what you need to know about that. Azure Databricks is an enterprise-grade and secure cloud-based big data and machine learning platform which is going to help you to perform data engineering on Azure Cloud. Azure Databricks provides similar notebooks-oriented Apache Spark as a service working environment that you get in Databricks, making it easy to manage, cluster, and explore data interactively. Here we are talking about Azure Databricks. It's the same that you get in the Databricks, it's integrated with Azure Cloud environment. Azure Databricks is a fully managed, cloud-based big data and machine learning platform which empowers developers to accelerate artificial intelligence and innovation by simplifying the process of building enterprise-grade production data applications. By combining the power of Databricks and end-to-end managed Apache Spark platform optimized for the cloud and with the enterprise scale and security of Microsoft Azure's platform, Azure Databricks make it simple to run large-scale Spark workloads. Over here, you should note that in this one you get the optimized environment as well. That means to address the problems seen on another big data platform, Azure Databricks was optimized from the ground up with a focus on performance and cost efficiency in the cloud. The Databricks runtime adds several key capabilities to Apache Spark workloads that can increase performance and reduce cost by as much as 10 to 100 times when running on Azure. And this includes high-speed connectors to Azure storage services such as Azure Blob Storage or Azure Data Lake. You can also get auto-scaling and auto-termination of Spark cluster to minimize your costs. Not only that, you would get caching, indexing, and advanced query optimization. Now, I always think that who is Databricks? Databricks was founded by the creator of Apache Spark, Data Lake, and MLflow. Over 2,000 global companies use the Databricks platform across big data and machine learning lifecycle. And that's why it's very important whenever you are migrating to any cloud services, whether it's Microsoft Azure, Google, or AWS, you should get this service. Databricks always have a vision to accelerate innovation by unifying data science and data engineering in businesses. And it provides big data analytics platform. What does Databricks offer that isn't open source Spark? Well, here you will get a lot of advantages. That means, first you get the Databricks workspace, which is interactive data science and collaboration, Secondly, you get the Databricks workflows, which is going to be for your production jobs and workflow automation. Then you get Databricks runtime, which is going to help you to connect with the different data sources and help you to process the data. Not only that, you also get Databricks input-output solution, which is optimized data access layer. Then you get Databricks serverless, which is a fully managed auto-tuning platform. And lastly, you will also get Databricks enterprise security, which is an end-to-end security and compliance. Now next question comes, what is Apache Spark? Well guys, as you already know, Spark is a unified processing engine that can analyze big data using SQL, machine learning, graph processing, or real-time streaming analysis. At its core is the Spark engine. The data frame API provides an abstraction above resilient distributed data sets, which simultaneously improving the performance 5 to 20 times over traditional resilient distributed data sets with its Catalyst optimizer. Not only that, additionally you get Spark ML, which provides high quality and finely tuned machine learning algorithms for processing big data. You also get the graph processing APIs. Lastly, the streaming APIs gives us end-to-end fault tolerance with exactly one semantics and the possibility for sub-millisecond latency, and all works together in the Apache Spark. Next, let's see where Azure Databricks sits. As you can see in this diagram, on the top of optimized Databricks runtime engine, we have Azure Data Services integration. And not only that, if you are a data scientist, then you can take the advantage of ML runtimes, which are PyTorch, TensorFlow, and Scikit-learn. And then on the top of that, you can use ML lifecycle management integrations, which is an integration of ML flow and machine learning. If you are a data engineer, then you can utilize Databricks input-output, Delta Lake optimize, Apache Spark, or serverless services when you are going to work on Azure Data Factory, Azure Synapse Analytics, Power BI, or Azure Data Lake Storage. Next, we are going to have a lab come demo session where we are going to create an Azure Databricks workspace and cluster. Hi, welcome to this lab session. In this one, we are going to create an Azure Databricks workspace and a cluster. There are mainly 3 steps involved in this demo. First of all, you have to log in into your portal.azure.com. You should have a subscription over there. If you don't have, please create it. You can refer the previous videos how to create it and how to start getting free credit from Microsoft Azure. Now, when you talk about the Azure Databricks workspace, we refer to 2 different things. The first reference is the logical Azure Databricks environment in which clusters are created, data is stored via DBFS, and in which the server resources are hosted. The second reference is the more common one used within the context of Azure Databricks. That is the special root folder for all of your organization's Databricks assets, including your notebooks, libraries, dashboards, etc. Now, the first step to using Azure Databricks is to create and deploy a Databricks workspace, which is the logical environment. So, how you are going to do that? First, as I mentioned, you have to log in into your Azure portal. Over here, you have to create resources. Let's click on this. And here, you have to search for the Databricks. Now, once you get the Databricks, you have to start creating it. That means you have to select from here Azure Databricks, which is our plan that we want to create, and just click on this create button. If you would like to review it, you want to learn something more about it, you can read it over here. Here, the very first you have to select your subscription, then your resource group, which is going to be BCP Learning. Here you have to provide it a meaningful name. So the name is up to you what you want to provide. That's the name I'm providing over here. And here pricing level, you have to select which you want to select. For example, if we select this premium, here you get 14 days free DPUs. So we are going to keep it as it is. Next, we can just simply review and create. That's all information you need to provide over here. It's validating, so it can take a few seconds. So please hold on. Now remember that once you click on this create button, this can take a few minutes. During your workspace creation, the submitting deployment for Azure Databricks title is going to appear over here, which is there, and you can see over here as well, deployment is in process. Meanwhile, you can go to your resource group where we have created this, and I have used this BCP learning, so I can come under this one. Here it's gonna show me all the resources which I have created so far, and here you can see BCP Azure Databricks is done, and in the notification also you can see that it's been deployed. You can directly go over here as well if you would like to, but I'm already here, so I really don't need to go over there. Once you found your new resource, that is BCP Azure Databricks that I have just created, you can just simply click inside it. And what we have to do, we have to go to the compute tab over here. So here, first of all, you have to launch your workspace. So click on this. And here it would take some time to launch your workspace. It's going to sign in into your Databricks. Now, once you are over here, you have to go to the compute part where you have to create a cluster. Otherwise, directly you can start from here where it's saying create a cluster. On the other hand, you would get all the information over here. You can directly come here under compute, and here you can also create a cluster. So we are getting started over here, so I can just close this, and here I can click on this create cluster button. Here you would get some of the information. First of all, you have to enter one cluster name. Then you have to select some of the cluster mode and Databricks runtime. I'm gonna keep it as it is, the way it is. Here, runtime you can select according to you. Over here, you can select out of this which one you want to select, and we are gonna keep it as it is, where we are gonna run Scala and Spark. Then over here, if you want to use the photon acceleration, you can select. Otherwise, autopilot options, please enable them. Then you have to also select your work type. I'm gonna keep them as default. I really don't want to change anything. However, please remember that your cluster mode should be single over here. Now what I'm gonna do, I'm gonna make some of the changes over here. Whatever is appearing over here, it's standard. So first of all, I'm gonna change the cluster mode to single node over here. Then I'm also going to change my Databricks runtime version to runtime 7.3. Over here you can see that there are a lot of versions, so I'm going to just work on 7.3 LTS. And under this autopilot option, I'm going to leave it checked. And the last point over here is to select the node type. If you want to learn more about what is a node, then you can see that this information over here. And I'm going to make it to standard DS3 V2, which is already over here. Then I can simply click on this create cluster button. This would take some time, so please be patient over here. Now you can see that your test cluster has been created. So what you can do, you can come over here on this tab, and here you can start creating your very first notebook. First, you can check your workspace. Over here, you would get your workspaces there, and in this create and create a new notebook. Here you can give it any name you would like to. And here you can also select the language of your choice, which language you are more comfortable with to work on these notebooks. We are going to select Python. And here under cluster, you can select your cluster. Our cluster is this. Then simply click on the create button. Now, you should remember that if your notebook is attached to a cluster, then you can perform certain operations. That means you can detach your notebook from the cluster, you can restart the cluster, you can attach it to another cluster, you can also open the Spark UI, or if you would like to view the log files of the driver, you can also do it over here. Now, what we are going to do, we are going to work with the notebooks. First of all, we have to clone the Databricks archive. And how we can do that? We can import it. And how to import it? Well, this is another question. So in order to import it, first you have to come over here again. You have to click on this workspace button here. And now in the workspace, you have several options, and we are going to say import. And now question is, from where to import? So we are going to click on this, and it's going to ask us whether you want to import from a file or from URL. We'll say URL and just paste this URL. I'm going to provide you this URL in the resource material. Click on this import button, and here we have to select the Introduction to Azure Databricks folder. This is the one that we have, and here we are going to use the set of notebooks in this folder to complete this lab. These are going to be our scripts that we are going to use, and here you can simply run each of them one by one. So how to run it? First of all, it's very simple example where you are going to just print the Python, and if you are already working on Python, you can simply use it. As I mentioned previously, if you want to run it, it's going to ask you for the cluster. If you want to change cluster, you can change it and you can attach and run. That's all you have to do. So it would take some time, and you can see that I'm running Python, it's working fine. If you want to change it, you can again run it. So there's a run button, run in the cell, and that's how you can run all of these one by one. And there are some of the information as well. If you would like to use it, please do use it, and you can complete your lab over here. That's all for this lab. Now question comes, what's next? In the next part, we are going to discuss about Spark architecture fundamentals. Azure Databricks provides a notebook-oriented Apache Spark as a service workplace environment. It is the most feature-rich hosted service available to run Spark workloads in Azure. Apache Spark is a unified analytics engine for large-scale data processing and machine learning. Suppose you work with big data as a data engineer or as a data scientist, and you must process data that you can describe as having one or more of the 3 V's of big data. That means high volume, high velocity, and variety. When it comes to working with big data in a unified way, whether you process it in real time as it arrives or in batches, Apache Spark provides a fast and capable engine that also supports data science processes like machine learning and advanced analytics. So, in this one, first we are going to discuss about architecture of Azure Databricks Spark cluster. So let's first understand about the architecture of Azure Databricks Spark cluster. In this high-level overview diagram, you can see that the Azure Databricks services launches and manages Apache Spark cluster within your Azure subscription. Apache Spark clusters are a group of computers that are treated as a single computer and handle the execution of commands issued from a notebook. Using a master work type architecture that you can see right now, clusters allow processing of data to be parallelized across many computers to improve scale and performance. They consist of Spark driver, which is the master, and work nodes. The driver nodes send work to the worker nodes and instruct them to pull data from specified data source. In Databricks, the notebook interface is the driver program. The driver program contains the main loop for the program and creates distributed data sets on the cluster. Then applies operations, that means your transformations and other actions, to the data sets. Microsoft Azure manages the cluster and auto-scales it as needed based on your usage and the setting used when configuring the cluster. Now see, what is under the cover? Well, under the cover, you would find your cluster that we have created, and there you have a workspace. Under the workspace, you would find everything. When you create an Azure Databricks service, a Databricks appliance is deployed as an Azure resource in your subscription. At the time of cluster creation, you specify the type and the size of the virtual machines to use for both the driver and the work nodes, but Azure Databricks manages all other aspects of the cluster. As we are discussing under the covers, you should also note that internally Azure Kubernetes Service or AKS is used to run the Azure Databricks control plane and data planes via containers running on the latest generation of Azure hardware or DV3 VMs with NVMe SSDs capable of blazing hundreds US latency on input-output or I/O. These make Databricks input-output performance even better. In addition, accelerated networking provides the fastest virtualized network infrastructure in the cloud. Here, we are going to discuss about the architecture of a Spark job. When you execute a Spark job, basically the driver is the JVM in which our application runs. Then, you should also remember that the secret of Spark's awesome performance is the parallelism. That means in parallel, you execute multiple JVMs. Now, if we talk about the jobs and stages, Over here, there are certain points that you should note. For example, each parallelized action is referred to as a job. The results of each job is returned to the driver, and depending on the work required, multiple jobs will be executed. Each job is broken down into several stages, and this would be analogous to building a house. For example, we are considering it as a job. The first stage would be to lay the foundation. The second stage would be to erect the walls, like you do while building a house. The third stage would be added to a room. And lastly, attempting to do any of these steps out of the order just won't make any sense. Next, we're going to talk about cluster management. At a much lower level, Spark Core employs a cluster manager that is responsible for provisioning nodes into our cluster. Databricks provides a robust, high-performing cluster manager as a part of overall offerings. In each of these scenarios, the driver is running on one node, with each executor running on n different nodes. And for the sake of this learning path, let's consider we don't need to concern ourselves with the cluster management because Azure is going to take care of it. And from our developers and learners perspective, our primary focus should be on the number of partitions my data is divided into, or the number of slots I have for parallel execution, or how many jobs I am triggering. And lastly, we should also think about the stages those jobs are divided into. That's all we need to think about it. In the next part, we are going to integrate Azure Databricks with Azure Synapse. There are certain objectives. That means first we have to access Azure Synapse Analytics from Azure Databricks by using the SQL Data Warehouse connector. Secondly, we are going to read from and write to Azure Cosmos DB from Azure Databricks. So what you have to do, you have to simply click on this show database connection string, or also you can click over here on your left hand side pane, connection strings. Here we have to copy this JDBC one, which is going to be the first one, which is SQL authentication. We have to copy this one and paste it over here. So this is going to be our connection string, and we have to replace this part with our password. And now we can even open our Synapse Studio if we have to work further. But before that, since we have configured JDBC connection string over here, now we have to create a master key and a table in Azure Synapse Analytics. Go to our Azure Synapse Analytics account, and there we have to select firewalls and virtual networks. So let's go to our Synapse Analytics account. Now over here we have to check our firewall settings. For that you have to come under security, and under security we have a couple of options, that means encryption, networking, identity, etc. So let's select over here networking. Under networking we have to add a client IP. So just click on this add client IP. It's going to be added over here, and now it's been done. So we are going to say allow Azure Synapse link for Azure's SQL database to bypass the firewall rules. Just select this option and save it. Now what we have to do, we have to go to the query editor, and in the query editor we are going to run a script. Let's open this in Synapse Studio. We have to run a query so that we can create a master key in Azure Synapse Analytics. Here we would come under data, and under data you can see that we have SQL database. So this is my dedicated SQL pool that I have created, and here I can run a query, and this is saying new script, so we can run it over here. So let's create this, and here I'm going to paste this script, which is going to create a master key, and here we can just run it against this database. So let's run it, and you can see that this query has been successfully completed. Now we have to execute one more query to create a staging table for the customer table. So this query is going to create one empty table in the same schema as the customer table. So what I can do, I can just click on this SQL pool and say new empty script, This is going to be my another script. I'm going to paste this script over here. You can see that it's using dbo.dim customer staging, and it's going to create one empty table. So run it. It will take some time, and here you can see that this query has been executed successfully. Now coming to the blob storage account, we have to create one blob storage account as well. And in order to do that, you have to go to again on your portal. This is going to be my main portal, my Azure portal. Here you can see that over here create resource, and you can select your blob storage account. But I have already created under my resources. If I'll go to this BCP learning, here you can see that I have different type of accounts, and we just need to check our storage account. So one of them is this Databricks Synapse, which is my another storage account that I created. And here you can find all the information regarding this. Remember that this Databricks Synapse or the account that you are about to create, it should belong to the same resource group where you have created your Synapse account. Otherwise, it's not going to work. And you should create it under storage v2 or general purpose v2 only. That's how you can use it, and then you can define certain other parameters as well. You would find it then when you are going to create a storage account. And if you don't know how to create a storage account, please go back and check the initial videos where I have showed how you can create one storage account. So we are going to use this storage account. So let me copy this and paste it over here. All right. Now what we have to do, we have to create one container over here, and we are going to give a name to this container. So let's create new container over here. So come to this container. Right now I have storage Databricks container already, so we can use this. So let me just copy this name. If you want to create a new one as well, you can do that. Just go one step back. Here you have to click a new container, just provide a name, and then you have to provide the access level. What kind of access level you want to provide? You can simply say private, no anonymous access. That's all you need to do. I'm going to discard it. Now there are some access keys, so we have to copy the access key as well, and this is going to be my storage account name as we have already copied. Now I need this key, so I'm gonna copy this key as well. So this is all you need to do initially to first set up your Azure Synapse Analytics account. Then you have to also set up a container and master key into your dedicated SQL pool. In the next part, what we are going to do, we are going to integrate it with Azure Synapse Analytics account. That means we are going to integrate Azure Databricks with Synapse Analytics. So how we are going to do that? For that, first you should have a workspace, and I have already one workspace over here. So I'm going to go back again. So if I'm going to show you this one, so this is going to be my workspace that we can use it, that we created earlier, and here we can create a new notebook over here. So now what you have to do, you have to come under this Databricks tab where you would find this workspace option. You have to go to your users. Under users, you have to click this drop down, and here you have to import. And over here under this option, import notebooks, we are going to clone the Databricks archive. So click on this import button, and here after some time you will find one folder. So let's wait for that. You can see that Synapse is there, and there is a notebook with the name Azure Synapse Analytics. So now this is going to be a notebook, and here you would find all the information that you would like to use. You have to simply run each of them one by one to do the analysis. I'm going to provide you this link in the description section. So let's run all of them one by one. Over here you can see that the learning objective is, by the end of this lesson you should be able to describe the connection architecture of Synapse and Spark, configure a connection between Databricks and Synapse, read the data from Synapse, write the data, and there is some of the diagram that is going to help you to understand how Synapse connector is going to work. It uses Azure Blob Storage as an intermediary. It uses Polybase in Synapse. It enables massive parallel processing reads and write to Synapse from Azure Databricks. And here some information about SQL DW connection, which is our dedicated SQL pool. So over here, as you can see that it's first asking you your storage account name, container name, and access key that you have to replace over here. So let's do that. That's all you need to mention. You don't need to mention any other keys. It's going to take these parameters over here. You have to simply run it. So run the cell. You have to also mount or attach a cluster, which is going to be this one. So attach and run. And here you can see that command took 0.05 second by connect@biconsultingpro.com, which is my user ID over here. So as you can see that this has been run successfully. Similarly, you have to run all other commands, and in case you encounter any of the error, please do let me know. Over here, you need to make sure that you have all the required tables over here and they have the right data inside them. Otherwise, it's not going to work. And then you have to run all the scripts one by one. That's all guys for this video. In the next part, we are going to discuss about the best practices in Azure Databricks. Imagine you are working as a data engineer for a Fortune 500 enterprise. Your organization has been using Azure Databricks heavily for large-scale data processing and data science workloads for a couple of years. Given these high workloads and exponential data growth that comes with it, it has become apparent that your Databricks environment might not be configured using best practices. Then, what are those best practices and what you should do? You will get to know in this video. Once you complete it, you will learn the best practices of workspace administration, security, tools and integration, Databricks runtime, and clusters. So let's first understand workspace administration best practices. Azure Databricks, or ADB, is a big data analytics service. Being a cloud-optimized managed platform as a service offering, it is designed to hide the underlying distributed systems and networking complexity as much as possible from the end user. It is backed by a team of support staff who monitor its health, debug tickets filed via Azure, etc. This allows ADB users to focus on developing value-generating apps rather than stressing over infrastructure management. Over here, you can see that multiple clusters can exist within a workspace, and there is a one-to-many mapping between a subscription to workspaces and further from one workspace to multiple clusters. So, with the basic understanding of this, what we are going to do, we are going to discuss how to plan a typical ADB or Azure Databricks deployment. We first grapple with the issue of how to divide workspace and assign them to users and arms. So, what should you do? The very first, you have to map workspaces to business divisions so that you can get to know how many workspaces do you need to deploy. So in order to answer to this question depends on a lot of your organization structure. And what we can recommend is that you assign workspace based on a related group of people working together collaboratively. For example, in your enterprise, you have multiple subscriptions. Then you have certain account owners, then departments, then enterprise. So that's how you can split them. Secondly, you can deploy workspaces in multiple subscriptions to honor your Azure capacity limits as well. Next, we are going to discuss about list security best practices. Security and infrastructure configuration go hand in hand. When you set up your Azure Databricks workspace or workspaces and related services, you need to make sure that security considerations do not take a backseat during the architecture design. To deploy multiple Azure Databricks resources in multiple subscriptions, you also have related services such as an Azure SQL database that are hosted in a VNet and need private access to Azure Databricks. So what you have to do, you have to first consider isolating each workspace in its own. Then you have to also remember, do not store any production data in default Databricks file system folders. Next, you have to always hide secrets in a keyboard. Next, you have to also manage access control, that means into your Azure Data Lake storage pass-through. And lastly, don't forget to configure audit logs and resource utilization metrics to monitor the activity over there. Next, let's discuss about tools and integration best practices. Now that you have configured your workspace and security, you need to consider tools used for development and data movement orchestration, as well as integration and other services. For that, you have to follow certain best practices. For example, you have to favor cluster scoped init scripts over global and named scripts. You can check Microsoft Azure website for init scripts, where you would find many different modes, for example, global, cluster named, or cluster scoped. Next, you have to use cluster log delivery feature to manage logs so that you have clear understanding about them. Then there are certain additional considerations as well. That means, first you have to use Azure Data Factory to orchestrate pipelines or workflows. Secondly, connect to your IDE. Then sync notebooks with Azure DevOps for seamless version control. Also, you can use Databricks CLI for CI/CD from relevant enterprise tools product, or to integrate with other systems like on-prem SCM or library repos, etc. Lastly, what you can also consider is to use library utilities to install Python libraries scoped at notebook level. Next, we are going to talk about Databricks runtime best practices. With workspace administration, security configuration, and tooling out of the way, it is time to consider optimizations based on your day-to-day task as a data engineer. Making best use of your resources will go a long way towards reducing overall operational overhead. And in that very first comes tune shuffle for optimal performance. A shuffle occurs when we need to move data from one node to another in order to complete a stage. Depending on the type of transformation, you may cause a shuffle to occur. This happens when all the executors require seeing all of the data in order to accurately perform the action. If the job requires a wide transformation, you can expect the job to execute slower because of all the partitions need to be shuffled around in order to complete the job. For example, group by or distinct. So you have got to control knobs of a shuffle you can use to optimize, and for that you can even run certain scripts. So for more information about that, you can check the Microsoft documents, where you would find certain scripts to run for the number of partitions being suffered, etc., or to check the number of partitions that you can compute in parallel. Secondly, you can consider to partition your data. In this type of best practices, this is a broad big data best practice, not limited to Azure Databricks itself. So whenever you are working on any kind of data which is going to be, tens of GBs per partition, etc., you can consider to partition your data. For example, you have data of hundreds of GBs, then you can definitely consider to partition your data, because that's going to be helpful to easily process it. Additionally, you can consider to use data lake whenever you can to get the best performance and reliability for your big data workloads and to create no-fuss multi-step data pipelines. You can also use machine learning runtime for working with the latest MLTL libraries. You can also consider to use Delta Cache for accelerating reads from blob storage or Azure Data Lake storage, or to turn on Databricks Advisor for automated tips on how to optimize workload processing. Finally, we are going to discuss about cluster best practices. Finally, it is time to think about the workhorse of your Azure Databricks jobs, that means the cluster. As you can recall, no one has re-evaluated the types and sizes of cluster in the workspace for several years. To allocate the right amount and type of cluster resource for a job, we need to understand how different types of job demand different types of cluster resources. And you can do this with the different scenarios. For example, in case of machine learning, it requires a different kind of cluster configuration. For streaming data, it would be different. For ETL, it would be different. And for interactive development workloads, it's going to be different, because in case of interactive development workloads, the ability for a cluster to auto-scale is most important. Now, another big question comes when you have to choose the VM type. So we have different Azure VM instances. So as you can see on your screen, we have different Azure VM instance types. We have based on compute optimized, memory optimized, etc. Also, we have different kinds of Azure VM instance type information as well. Like, for example, if I have a compute optimized of FS, then how much RAM or how much SSD I can get it. So you have to always keep in mind which one to choose while configuring your cluster. Not only that, there are some rules of thumb as well. That means fewer big instances are always more than the more small instances. This is going to help to reduce network shuffle. Also, you can apply this to batch ETL mainly. And lastly, not set in stone and reverse would make sense in many cases. So sizing exercise matters. Secondly, size based on the number of tasks initially. We can check the number of tasks and then based on that we can resize our cluster and later we can tweak it according to our requirement. Then last option would be to choose based on the workloads. Initially we can start with F series and later on we can also change it. I hope now you are feeling confident enough after watching this video tutorial and you are ready to kickstart your career with Azure Databricks. If you have any question or concern, please don't forget to let us know. If you have some query and you want to directly connect with us for any training or consultation, please connect with us at connect@biconsultingpro.com. You can also visit our website, that is www.biconsultingpro.com. If you are over here for the very first time, then please don't forget to subscribe our channel and hit the bell icon for all the latest videos and tutorials. See you in the next video.